welcome to Sleepy Story Facts, and to this very special sleep story that has been created just for you, for this quiet moment, for the exact space you are resting in right now, whether you are tucked beneath a soft blanket, lying with your head gently settled into your pillow, or simply finding stillness wherever the night has found you. This is your invitation to let everything slow down, the noise of the day, the thoughts that have been circling, the little urgencies that felt so important just a few hours ago. You can allow all of them to soften now, like the last light fading from the edge of a winter sky. This is a gentle bedtime story, and it has been made with great care to carry you slowly, unhurriedly, toward deep and restful sleep. Tonight's relaxing story is unlike any other, because it does not begin on Earth. It does not begin in a forest or beside a quiet sea. Tonight, this calming narration begins at the very edge of everything, at the moment in the life of the universe, before a single star had ever burned, before a single photon of light had ever crossed the vast and patient darkness, in the era that scientists call the cosmic dark ages. So before we begin the journey, let yourself arrive fully in this moment. Feel the weight of your body resting completely against the surface beneath you. Let your shoulders drop just a little. Let your jaw soften. Let your hands lie open and still. If there are any sounds around you, you do not need to push them away. Simply let them pass through, like wind through tall grass, and return your attention gently to this voice. Take one slow breath in through your nose. Hold it softly for just a moment, and release it in a long, calm exhale through your mouth. And again, a gentle breath in and a slow, quiet breath out. There is nothing you need to do, nowhere you need to be, and nothing you need to remember tonight. You only need to listen and rest, and let this nighttime story carry you. The universe, as scientists now understand it, is approximately 13.8 billion years old. That number is so large, it almost dissolves into meaninglessness if you try to hold it all at once. And that is perfectly fine, because this calming bedtime story will not ask you to hold it. Instead, it will invite you to simply float through it, the way a feather floats down through still evening air, without effort, without destination. Just the slow, easy drift of something weightless moving through something quiet. In the very beginning, after the event that cosmologists call the Big Bang, the universe was extraordinarily hot and extraordinarily dense. A place of unimaginable energy, nothing like the vast, cool darkness we now call space. But the universe expanded, and as it expanded, it cooled, and as it cooled, something remarkable and deeply peaceful happened. The frantic energy of those first moments began to settle. Particles that had been too hot to stay together began to combine. Electrons and protons found one another and formed the very first hydrogen atoms, the simplest atoms in existence. A single proton, a single electron, resting together in a kind of primal quiet. This moment, which happened roughly 380,000 years after the Big Bang, is called recombination, and it is one of the most serene turning points in the entire history of the cosmos. Before recombination, the universe was opaque, so full of free electrons evidence that light could not travel more than a tiny distance before being scattered and absorbed, like trying to see through the thickest, warmest fog. But after recombination, the fog began to clear. The universe became transparent for the first time, and a soft, ancient glow, the light released from all that cooling energy, streamed outward in every direction. Scientists today can still detect that ancient glow. They call it the cosmic microwave background, and it whispers to our instruments like the last faint warmth of a fire that burned almost 14 billion years ago. After that first release of light, something unexpected happened, something that feels, when you hold it slowly and gently in your mind, almost like the universe itself taking a long, deep, resting breath. The light faded, the energy dissipated, and the cosmos entered a period of profound, unbroken darkness that lasted for hundreds of millions of years. No stars, no galaxies, no light of any kind crossing the enormous, slowly expanding ocean of space. Only hydrogen gas, cool and still and patient, drifting in vast, invisible clouds, pulled here and there by the invisible hand of gravity, gathering almost imperceptibly, slowly, into the seeds of what would, in time, become the very first stars. This era, this long, dark, unhurried pause in the story of the universe, is what astronomers call the cosmic dark ages, and it is where this sleep story truly begins, in the silence before the first light, in the darkness that preceded every star you have ever seen. As you settle even more deeply into the comfort surrounding you right now, let your body grow heavier, let your thoughts grow quieter, and allow this relaxing story to carry you gently forward through the vast and patient darkness of the early universe. There is nothing sharp here, nothing sudden, nothing that will startle or rush you. The cosmic dark ages stretched across an almost incomprehensible span of time, from roughly 380,000 years after the Big Bang, all the way to somewhere near 150 to 200 million years after it. And during that entire long, unhurried era, the universe did something that feels, in the softest and most restful way, deeply familiar. It simply waited. The hydrogen atoms that had formed during recombination drifted through the expanding dark in enormous, slowly moving clouds. And those clouds were not uniform. Some regions of space were ever so slightly denser than others, fractionally heavier, infinitesimally more concentrated, as though the universe had exhaled unevenly across its own vast surface, leaving behind the gentlest of ripples in an otherwise still and featureless ocean. These tiny variations in density, so subtle that they would be invisible to any eye, were nonetheless the seeds of everything that would ever exist. Every star, every galaxy, every world that would one day turn slowly in the light. Gravity, that most patient and persistent of forces, began its quiet work. It did not rush. It did not announce itself. It simply pulled, gently and continuously, drawing hydrogen atoms closer together in those denser regions, the way a slow current in a deep river gently draws fallen leaves toward the same still corner of the water. Over millions of years, these clouds grew denser at their cores. The hydrogen pressed inward from all directions, following the invisible architecture of gravity, like water, finding its way downhill through dark and unmarked terrain. And still, there was no light. The universe during this era was not merely dark in the way a room is dark when the lights are switched off, with the memory of brightness still somehow present in the walls and the furniture. It was dark in a way that had no reference point, no contrast, no edge. It was a darkness that had never known light, except for that one ancient glow already fading into the far infrared, already cooling toward invisibility, already becoming something too faint and too stretched by expansion to be called light in any familiar sense. If you can imagine floating in that darkness now, not with fear, but with the same easy weightlessness of a dreamless sleep, you might feel how profoundly still it was. No sound, because sound requires a medium dense enough to carry it in any meaningful way across those distances. No warmth, because the ambient temperature of the universe had dropped to just a few degrees above absolute zero. No motion visible to any eye, because everything that moved did so across timescales so enormous that a single human lifetime would not have registered even the smallest measurable change. This is one of the most deeply calming facts in all of science, that the universe itself, the entire cosmos, once rested. It entered a long, dark, undisturbed stillness and simply allowed gravity to do its slow and gentle work without interruption. The clouds of hydrogen continued to contract at their densest cores. And as they contracted, something that physicists call gravitational potential energy began to convert slowly into heat. The cores of these collapsing clouds grew warmer, not quickly, not dramatically, but with the same patient inevitability as a stone that has been sitting in sunlight all afternoon, warmer and denser and more compressed over millions upon millions of years, while the rest of the universe remained dark and quiet all around them. This is the bedtime story of the universe before its first morning, and it is a story that has no urgency, no conflict, no sharp edges. It is only the story of time doing what time does, of gravity doing what gravity does, of matter following the invisible instructions written into the geometry of space itself, all of it unfolding in a silence so complete and so ancient that it makes the quietest night you have ever known feel almost busy by comparison. As you breathe slowly and rest in the darkness of your own quiet room, you are in some small way echoing that primordial stillness, that long, dark, unhurried pause before the first light. You are part of a universe that has always known how to wait, how to rest, how to let things gather and grow in the dark without forcing them, without rushing toward the morning before the morning is ready to arrive. The first stars are coming, but not yet. For now, there is only the dark and the drift and the slow, deep, comfortable pull of gravity drawing everything gently toward its eventual radiance. Let yourself sink a little deeper now into the stillness that surrounds you, letting the weight of the day dissolve completely, letting your breath come and go in its own easy rhythm, slow and unhurried, like the long, gentle tide of a sea that has never known a storm. This calming narration will stay close beside you as we drift further into the deep dark of the early universe, into that extraordinary era of patience and quiet gathering, when the cosmos was doing something that requires no effort to understand and no energy to follow. It was simply allowing things to fall together, softly and slowly, in the dark. The hydrogen clouds we left behind in the last part of this sleep story were not static, though nothing about them would have appeared to move on any human timescale. They were alive with the slow mathematics of gravity, each atom exerting its infinitesimal pull on every other atom, the densest regions drawing more material inward, growing denser still, in a process so gradual and so unhurried that it feels, when you hold it gently in your mind, less like a physical event and more like the universe settling into a deep and dreamless rest. These collapsing clouds of hydrogen gas are what cosmologists call primordial gas clouds, and they existed in a universe that contained almost nothing else. There was no oxygen yet, no carbon, no iron, no calcium. None of the heavier elements that would later be forged inside stars and scattered across space when those stars ended their lives. The universe in this era was a place of extraordinary simplicity, composed almost entirely of hydrogen, with a smaller portion of helium formed in the first minutes after the Big Bang, and the faintest trace of lithium scattered here and there, like rare grains of something precious, dissolved in an ocean too vast to measure. This simplicity is itself a deeply relaxing thought. The idea that everything complex, everything intricate, everything layered and rich and varied that you have ever seen or touched or known, all of it grew from something so elementally simple, so quiet and so clean, as a dark cloud of hydrogen slowly falling inward under its own weight in a universe that had not yet learned to shine. As those clouds contracted, their cores grew denser, and the hydrogen atoms within them were pressed closer and closer together. The temperature at the very center of these collapsing structures began to rise, not because anything was burning, but because the energy of all that inward motion had to go somewhere, and it went into heat, the same way that compressing air in a bicycle pump warms the pump slightly with each stroke. But the scale here was incomprehensibly larger, not a bicycle pump, but a cloud of hydrogen millions of times more massive than our own sun, compressing over millions of years, its core temperature climbing degree by patient degree toward a threshold that the universe had never yet crossed. Scientists call the structures forming during this period protostars, not yet stars in the full sense, not yet ignited, not yet radiating light into the surrounding darkness, but already something more than a cloud, already something with a center, a direction, a gathering purpose. The protostellar core glowed with heat, but it was a heat buried so deeply inside the surrounding envelope of gas and dust that no photon of light could escape outward into space. The energy was trapped, held close, building slowly, like the warmth that accumulates beneath a heavy blanket on a cold night, invisible from the outside, but quietly, steadily present within. Around these collapsing cores, the remaining gas in the cloud did not simply fall straight inward. It spiraled, following the gentle rotation that the original cloud had inherited from tiny asymmetries in the early universe. And this spiraling created what physicists describe as an accretion disk, a broad, slowly rotating halo of gas curving inward toward the central protostar, like the surface of a vast and silent whirlpool seen from an immense distance. There was still no light crossing the open universe. The darkness remained total, and it remained total not for days or years, but for millions of years more, as these protostars continued their slow, deep, inward journey toward the moment of ignition. And yet, there was something profoundly tender about this process. The universe preparing its first candles in complete darkness, assembling them with extraordinary patience, never hurrying, never skipping a step, following the deep and ancient laws of physics, the way a river follows a valley, without effort, without resistance, simply moving in the direction that the shape of things allows. As you rest here in your own gentle darkness, breathing slowly and feeling the comfortable weight of stillness all around you, you can let this image settle into your mind like a stone settling slowly to the bottom of a deep and peaceful lake. The universe, patient and dark, and full of quiet purpose, cradling the seeds of its first stars in the soft, invisible hands of gravity, waiting without urgency for the morning it had been building toward for 100 million years. Let your eyes stay gently closed, and let your breathing continue in that slow, easy rhythm that has been carrying you through this relaxing story. In and out, soft and unhurried, like the barely perceptible rise and fall of a calm sea at the end of a long and windless day. We are drawing closer now to one of the most extraordinary moments in the entire history of the cosmos. Not a loud moment, not a violent or frightening one, but a moment of such profound and patient culmination that it feels, when you approach it slowly and quietly, the way this gentle bedtime story is bringing you toward it, like the universe finally exhaling after holding its breath for 150 million years. The protostellar cores we have been drifting beside through the last chapters of this sleep story have been growing warmer and denser for an almost incomprehensible stretch of time. Hydrogen atoms at their centers have been pressed closer and closer together by the relentless, gentle patience of gravity, and the temperature in those innermost regions has been climbing degree by degree, million by million, toward a number that physicists describe as the ignition threshold for nuclear fusion. Approximately 10 million degrees Celsius. That number sounds dramatic when spoken aloud, but in the context of this calming narration, it is simply the quiet answer to a question that gravity had been asking for millions of years. The question of what happens when hydrogen is compressed long enough and patiently enough and completely enough that the atoms can no longer remain separate. The answer is fusion, and fusion is, at its most fundamental level, an act of joining. Two hydrogen nuclei, each a single proton, come close enough together that the strong nuclear force, one of the four fundamental forces of nature, and the one that operates only across the tiniest distances, reaches across the vanishing space between them and pulls them together into something new. The result is a helium nucleus, slightly less massive than the two hydrogen nuclei that formed it. And that small difference in mass, that tiny remainder that does not become helium, is released as energy. This is the process that Einstein described in his famous equation relating mass and energy, and it is a process of breathtaking efficiency. A single gram of hydrogen fuel, fully fused, releases as much energy as burning thousands of kilograms of coal. But it does so not in an explosion, not in a flash, but in a slow, steady, self-sustaining glow that can last for millions or even billions of years in the core of the universe's very first star. This process ignited for the first time in all of cosmic history. And when it did, something changed in the universe that had never been changed before. For the first time since that ancient, fading glow of recombination had stretched itself into invisibility, there was a new source of light in the cosmos. Not borrowed light, not residual light, but freshly made light, generated in the heart of a star by the joining of atoms that had been drifting in darkness since the universe began. These first stars are known to astronomers as population III stars, and they were unlike any stars that exist today because the universe at the time of their formation contained only hydrogen, helium, and trace amounts of lithium, with none of the heavier elements that would later seed the cosmos through stellar explosions. These first stars had nothing to slow their collapse, nothing to interrupt the gathering of mass, and so they grew enormous, some of them hundreds of times more massive than our own sun, blazing with an intensity that is difficult to comprehend, and yet, heard through the soft filter of this nighttime story, feels not fearsome but wonderful, like learning that the very first candle ever lit was in fact a lighthouse, warm and steady and vast, standing alone in an infinite and previously unlit dark. The light from those first stars did not simply illuminate their immediate surroundings. It began to travel, as light always does, outward in every direction at the only speed the universe permits for light, crossing the darkness that surrounded each star, reaching the cold clouds of hydrogen that drifted nearby, and beginning to interact with them in a way that would slowly, over millions more years, transform the entire nature of the cosmos. But that transformation is still just beginning, still just the first tender unfolding of a process that will take hundreds of millions of years to complete. And this sleep story will walk with you through every gentle step of it. For now, simply rest with the knowledge that somewhere in the darkness of the early universe, after a patience so vast it has no human equivalent, the first light finally arrived, quiet and warm and entirely, cosmically alone, burning in a darkness that it was only just beginning, one slow photon at a time, to change. Allow yourself to rest even more completely now, letting this gentle sleep story carry you like a slow current on a wide and silent river. No effort required, no direction to choose, simply the easy drift of a mind growing soft and a body growing still in the deep and comfortable quiet of the night. We have arrived at one of the most breathtaking and most peaceful images that science has ever offered to the imagination. A single star, the very first star, burning alone in a universe so vast and so dark that its light, for all its intensity, touched almost nothing for an almost incomprehensible distance in every direction. Picture that now, not with effort, but as softly as you would picture a single candle burning in a very large and very quiet room. The population III star that ignited in the darkness of the early universe was not the small, modest kind of star that our own sun represents. It was a giant, and scientists believe the first stars were among the largest that have ever existed anywhere in the cosmos. Some of them potentially hundreds of times more massive than our sun, blazing at temperatures so extreme that the light they produced was weighted toward the ultraviolet end of the spectrum. Hard and bright and richly energetic, the kind of light that carries enough power in each photon to strip an electron away from a hydrogen atom simply by passing close enough to it. And yet, for all that intensity, the star was alone. Around it, in every direction, stretched the same cold, dark, neutral hydrogen gas that had filled the universe since recombination. Undisturbed, unlit, patient, as only something truly ancient can be patient. The light from that first star traveled outward at the speed of light, which in the emptiness of the early universe meant it encountered almost nothing. Not another star, not a planet, not a grain of dust heavier than hydrogen or helium, just the slow, dark ocean of gas, vast and featureless, stretching away in all directions toward a horizon so distant it curved back on itself in the geometry of an expanding universe. This image, a single burning point of light surrounded by infinite darkness, is one that this calming narration invites you to hold very gently in your mind as you drift toward sleep, because it carries within it something that feels unexpectedly tender. The universe had spent 150 million years in complete darkness, not waiting impatiently, not straining toward the light, but simply being what it was, dark and cool and full of quiet potential. And then, in one place, in one collapsing cloud that had grown dense enough and hot enough to cross the threshold of fusion, it made something luminous, one star, one point of warmth in an unimaginable expanse of cold. The light from that star radiated outward into the surrounding gas in a slowly expanding sphere. And as it traveled, it did something that physicists call photoionization. It transferred enough energy to the hydrogen atoms it encountered to knock their electrons free, converting neutral hydrogen into ionized hydrogen, a plasma of free protons and electrons, in a slowly growing bubble of transparent space centered on the star. This bubble is called an HII region, and it was the very first clear space in the universe, the first volume of the cosmos, through which light could travel freely without being absorbed. A small sphere of newly opened sky carved by starlight out of the surrounding fog of neutral gas. That bubble was tiny compared to the universe, of course, a small cleared space in an ocean of darkness that stretched for billions of light years in every direction. But it was the beginning of something, the first tender punctuation in a text that had been blank for 150 million years, the first word in the long and still unfinished story of a universe teaching itself to shine. As you lie here in the soft darkness of your own room, breathing slowly, feeling the comfortable stillness of this nighttime story settle around you like a warm and weightless blanket, you can let that image move gently through your mind. that small sphere of cleared, transparent space, glowing faintly at its edges, where the ionizing light was still pressing outward into the neutral gas. And at its center, the star itself, enormous and brief and blazing, burning through its hydrogen fuel at a rate so prodigious that it would exhaust in a few million years what our own sun will take 10 billion years to consume. Brief by cosmic standards, but long enough, more than long enough, to begin the slow and patient work of reionizing a universe that had been waiting in the dark since long before the first star was even a whisper of extra density in a cloud of drifting gas. The first light was here, and the universe would never be entirely dark again. Let your body sink a little deeper now. Let your thoughts grow a little softer, and allow this relaxing story to continue its slow and easy movement through the ancient history of a universe that has all the time in existence and no reason to hurry anywhere at all. You have been drifting through the dark alongside the very first light ever made by a star. And in this part of our gentle bedtime story, that light is beginning to do something extraordinary, something that will take hundreds of millions of years to complete, and yet which began in the most unhurried and unassuming way imaginable. It began to change the universe, one hydrogen atom at a time, by simply being present, by simply shining outward into a darkness that had never before encountered the particular kind of energy that a burning star produces. The HII region we visited at the close of the last chapter, that small, slowly expanding sphere of ionized, transparent space surrounding the first star, was growing. It grew not in dramatic surges or sudden expansions, but in the same patient, continuous way that a drop of warm water spreads through cold, still air, pressing outward at its edges with quiet persistence, converting neutral hydrogen atoms into free protons and electrons, simply by delivering enough photon energy to break the gentle bond between them. Each photon that the first star released traveled outward at the speed of light until it encountered a neutral hydrogen atom at the boundary of the ionized bubble. And there, it gave up its energy in a single, silent transaction, electron freed, atom ionized, boundary of the bubble nudged infinitesimally outward into the dark. Multiply that transaction by the unimaginable number of photons a star of that size and temperature produced every second. And the bubble grew slowly, but without pause, like a sphere of waking spreading through a universe still deep in its long primordial sleep. Beyond the edge of that bubble, the universe remained exactly as it had been: cold, dark, neutral, filled with the same patient hydrogen gas that had been drifting through the expanding cosmos since recombination. The boundary between the ionized interior and the neutral exterior was not a sharp wall, but a gradual transition, a soft and slowly moving frontier where the density of ionizing photons decreased with distance from the star, where the conversion of neutral hydrogen to plasma became less and less complete, fading from fully ionized near the star to partially ionized at the boundary, to completely neutral just beyond it, like the edge of a circle of firelight on a very dark and very quiet night. This is one of the most deeply calming structures in all of astrophysics. Not a collision, not an explosion, not a violent remaking of the universe, but a slow and steady illumination, a gentle pressing of light against darkness, along a front that moved outward at a pace determined entirely by how many photons the star could produce, and how many hydrogen atoms stood between the star and the edge of its growing sphere of influence. Scientists who study this era use the term cosmic reionization to describe the full process by which the universe transitioned from a state of complete neutrality. Every hydrogen atom intact, every electron bound to its proton, to a state of nearly complete ionization, in which the vast majority of hydrogen in the intergalactic medium had been stripped of its electrons by starlight. That full transition would not be complete for hundreds of millions of years after the first star ignited, and it would require not one star, but an entire generation, and then another, of massive burning suns scattered across the growing cosmic web. But it began here, with this one bubble, with this one star, with this one slow and quiet expansion of light into dark, that this nighttime story has been holding gently in its hands for you to rest beside. There is something in this image that feels almost like breathing, the universe expanding, and the light expanding with it. The bubble of ionized space growing larger with every passing million years, the darkness retreating not because it was defeated, but because the light was patient and persistent, and entirely without urgency, present in every direction simultaneously, pressing outward with the same even, unhurried pressure on every part of its expanding boundary. As you breathe slowly in the quiet of this calming narration, in and out, soft and easy, you can let that image become your own. The light moving outward in every direction at once, not rushing, not straining, simply traveling at the only speed it knows, carrying warmth and transparency, and the first hints of a universe learning to see itself, while you rest here in your own small and comfortable darkness, drifting gently toward the deep and restful sleep that has been waiting for you all along. Rest here now, softly and completely, letting this gentle sleep story hold you in its slow and steady current, your breath moving in and out without any effort at all, your thoughts drifting like the last few leaves of autumn on a completely still and perfectly quiet pond. We have been traveling together through the earliest chapter of the universe's long and patient story. And in this part of our calming narration, we arrive at something that might at first seem like an ending, but which is, in the most profound and most peaceful sense, the opposite. The moment when the universe's first star, having burned with extraordinary brightness for a few million years, reached the natural conclusion of its brief and blazing life, and in doing so, gave the cosmos something it had never possessed before, something that would make every star that followed richer, every world more complex, and every form of life that would eventually emerge from the long, slow unfolding of cosmic time more possible. Population III stars, those first enormous burning giants composed entirely of hydrogen and helium, lived fast by stellar standards. Our own sun, a modest and medium-sized star, will burn steadily for approximately 10 billion years before exhausting the hydrogen in its core. But a star hundreds of times more massive burns through its fuel at a rate so much greater that its lifetime is measured not in billions of years, but in millions. A cosmic instant, a brief blazing passage through the dark that nonetheless accomplished more in those few million years than the preceding 150 million years of darkness had been able to accomplish in all their patient stillness. As the core of a massive population III star consumed its hydrogen fuel, it began fusing helium into heavier elements: carbon, oxygen, neon, silicon, moving progressively up the periodic table of elements in a sequence of fusion reactions that each released less energy than the last, each burning faster and more desperately than the one before, until the core attempted to fuse iron. And here the star encountered a wall it could not cross, because fusing iron requires energy rather than releasing it. And so the fusion process stopped, and the core, no longer supported against the inward pull of its own enormous gravity, collapsed in a fraction of a second. What followed was one of the most energetic events in the universe, a core collapse supernova. But this sleep story will not linger on the drama of that moment, because what matters here, what is genuinely worth holding gently in your mind as you drift toward deep and restful sleep, is not the explosion itself, but what the explosion left behind in those final seconds. The collapsing core generated temperatures and pressures so extreme that entirely new elements were forged. Elements heavier than iron. Elements that had never existed anywhere in the universe before that moment. Gold and silver and platinum and zinc and a dozen others, created in the last heartbeats of the first star, and then scattered outward by the supernova's expanding shockwave into the surrounding space. And with those newly forged, heavy elements went all the lighter elements the star had spent its lifetime creating. The carbon, the oxygen, the silicon, the sulfur, all of it released from the star's interior and sent drifting outward into the dark, mixing with the surrounding hydrogen gas, enriching it, transforming it from the simple elemental mixture it had been since the Big Bang into something more complex, more varied, more full of possibility. This process, the enrichment of the interstellar medium by stellar nucleosynthesis and supernova dispersal, is what astronomers call chemical enrichment, and it is the reason that every star formed after the first generation was slightly more complex than those that came before, slightly better equipped to form planets, slightly more capable of producing the conditions that would, billions of years later, allow something as improbable and as wonderful as life to emerge from the chemistry of a warm and watery world. As you lie here in the comfortable darkness of your room, breathing slowly and feeling the deep and easy weight of rest settling over you like a soft and familiar blanket, you can let that thought move gently through your mind, that the iron in your blood, the carbon in your cells, the oxygen in every breath you are taking right now, was made in a star, scattered by a supernova and carried across billions of years and billions of light years to become, eventually and improbably and beautifully, you resting here in the quiet, listening to this nighttime story about the very star whose death made your existence possible. Let your breathing slow a little more now. Let your body grow heavier and softer against everything that is supporting you. And allow this relaxing story to continue its gentle and unhurried movement through the deep history of a cosmos that has never once been in a hurry and has always found its way to something more beautiful than what came before. We left the universe in the quiet aftermath of its very first supernova, with the expanding shell of enriched gas from the first star drifting slowly outward into the surrounding dark, carrying with it the first carbon, the first oxygen, the first silicon ever to exist anywhere in the cosmos. And now, in this part of our calming narration, we drift alongside those elements through the dark, watching them travel, watching them cool, watching them begin the long and patient process of mixing with the primordial hydrogen and helium gas that still filled the overwhelming majority of the universe in every direction. And in doing so, seeding the next chapter of the cosmic story with a richness and a complexity that the universe had not possessed even a few million years before. The expanding supernova remnant moved outward from the site of the first star's death in a slowly decelerating shell, its edges cooling as it traveled, its material thinning as it spread across an ever larger volume of space. At its leading edge, it compressed the surrounding neutral hydrogen gas into denser filaments, creating regions of slightly elevated density that would, over time, become the seeds of new collapse, new protostars, new ignitions of fusion in the dark. But this second generation of stars, the ones astronomers call population II stars, would be different from their predecessors in one quiet but profoundly important way. They would be born from gas that already contained traces of carbon and oxygen and other heavy elements, and those traces, however small, would change the behavior of the collapsing gas clouds in ways that would shape everything that followed. Heavy elements like carbon and oxygen are extraordinarily efficient at radiating away heat. When a collapsing gas cloud contains even tiny amounts of these elements, the cloud can cool more quickly as it contracts. And faster cooling means the gas can fragment into smaller pieces before the central pressure builds high enough to halt the collapse. This fragmentation means that instead of producing one single enormous star, a cloud enriched with even a small amount of heavy elements might produce many smaller stars, clustered together, each one less massive and therefore longer-lived than the giants of the first generation. This shift from massive, brief population III stars to smaller, longer-lived population II stars was one of the most consequential transitions in the history of the universe, and it happened not through any sudden event, but through the slow, quiet accumulation of chemical enrichment, supernova by supernova, generation by generation, each dying star leaving the next generation of clouds a little richer, a little more capable of fragmentation, a little more inclined to produce the smaller and more modest stars that would eventually come to populate the galaxies we see today. As you rest in the deep and comfortable quiet of this nighttime story, breathing slowly and feeling the gentle pull of sleep growing stronger With each easy breath, you can let the image of that process unfold softly in your mind. The universe enriching itself in the dark, each generation of stars building on the legacy of the one before. The cosmos becoming gradually more complex, more varied, more capable of eventually producing the conditions for worlds and water and warmth, all of it unfolding with a patience so immense that the entire span of recorded human history would not register as even the briefest pause in the longer rhythm of this story. The dark between the early stars was not empty in the way it had been before the first star ignited. It was now a dark threaded with chemistry, with the ghost of a star's long life written in the distribution of its scattered elements, with the invisible architecture of future possibilities drifting through the cold interstellar gas like seeds carried on a wind so slow it would take millions of years to deliver them to the soil where they would eventually rest and wait, and in the fullness of cosmic time germinate into something the universe had never yet imagined. You are part of that unimaginable thing, resting here in the quiet, carried forward by a chain of stellar generations stretching back to the very first light. Your existence, the latest and most tender gift of a universe that has been enriching itself in the dark since long before the earth existed, since long before the sun was born, since the very first star scattered its final breath across the patient and receptive darkness of the early cosmos. Breathe slowly now, easily and without effort, letting the air move in and out of your body in its own gentle rhythm, and allow this calming narration to continue its soft and unhurried passage through the deep history of a universe that has always known, even in its darkest and most patient eras, that something more was coming, that the quiet work being done in the dark was never wasted, never purposeless, always building toward the next quiet wonder in a story that has no real ending and no urgency and no reason to move any faster than the laws of physics and the geometry of space will allow. We find ourselves now in a universe that has changed in a way that is invisible to any eye, but deeply significant to the long arc of cosmic evolution. A universe whose interstellar gas, at least in the regions nearest to where the first stars lived and died, is no longer the same simple mixture of hydrogen and helium it was at the beginning. It is enriched now, threaded with the lightest dusting of carbon and oxygen and other heavy elements, and that dusting, however faint, is already beginning to change the behavior of the gas clouds that are slowly gathering themselves toward collapse in the surrounding dark. When a second-generation cloud begins to contract under gravity, it carries this inheritance within it, and the carbon and oxygen atoms dispersed through the cloud begin almost immediately to do what they do extraordinarily well. They radiate heat as the cloud compresses and the temperature at its interior rises. These heavy element atoms absorb some of that thermal energy and release it outward as photons, cooling the cloud more efficiently than pure hydrogen and helium ever could, allowing the contracting gas to fragment earlier in the collapse process, to break apart into multiple smaller concentrations rather than gathering all its mass into a single enormous center. The result is a generation of stars that looks nothing like the giants of the first generation, where population III stars were behemoths, blazing at hundreds of solar masses and exhausting their fuel in a cosmically brief few million years. Population II stars are smaller, more modest, more varied in their sizes, and dramatically longer-lived. A star of one solar mass, born from this enriched second-generation gas, will burn steadily and quietly for 10 billion years, and stars smaller than our sun will burn for even longer, some of them for hundreds of billions of years, far outlasting the current age of the universe. This shift in stellar character, from brief and enormous to small and enduring, is one of the most serene transitions in the entire history of the cosmos, because it represents the universe settling into a more sustainable and more varied relationship with its own light, moving away from the spectacular but fleeting brilliance of its first stars toward the steady, patient, long-burning glow of a mature stellar population that would eventually produce the conditions necessary for planets, for chemistry, for warmth, for life. As you lie here in the soft and comfortable dark of this nighttime story, feeling sleep drawing closer with each slow and easy breath, you can let the image of those second-generation stars come gently into your mind, not as blazing giants, but as quieter, smaller points of light, scattered more widely across the growing structure of the early universe, each one burning with a modest and enduring steadiness that feels, in the context of this sleep story, like the cosmic equivalent of a small lamp left burning in a window on a long winter night, warm and persistent, and quietly, reliably present. These population II stars are not entirely lost to us. Some of the smallest and oldest of them, the ones born from the earliest enriched gas clouds in the outer regions of what would become our own galaxy, are still burning today, billions of years after their formation, their ancient light reaching our telescopes as a faint but precious record of the universe's second chapter, carrying within their spectra the chemical fingerprints of the environment in which they formed, low in heavy elements, rich in hydrogen and helium, marked by the subtle signature of a cosmos that had only just begun to learn the art of building complexity from simplicity. When astronomers study these ancient stars, they are reading a letter written in starlight by the early universe, a letter that describes the conditions of a time so remote that no human framework of experience can truly contain it, and yet which feels, when approached slowly and gently through the medium of a calming bedtime story on a quiet night, not remote at all, but somehow close and warm and present, like the memory of something very old and very good that you have always known without knowing that you knew it. Let your body rest completely now, every muscle soft, every breath slow and easy and entirely without effort, as this gentle sleep story continues its quiet drift through the deep and unhurried history of the early universe, moving now into an era when the cosmos was beginning to do something new, something that would shape every structure we can see when we look up at the night sky from any quiet place on Earth. It was beginning to gather its stars, not as isolated individuals scattered randomly through the dark, but into clusters, and those clusters into larger associations, and those larger associations into the first faint, irregular, beautiful predecessors of the galaxies that today hold hundreds of billions of stars each and stretch across the observable universe in patterns so vast and so intricate that they have been compared by more than one astronomer lying awake in the dark, thinking about such things, to the delicate branching structure of neurons in a sleeping brain. The process that drove this gathering was the same one that had driven every act of cosmic assembly since the very beginning: gravity, patient and persistent, and entirely without agenda, pulling matter along the invisible pathways of what cosmologists call the cosmic web. This cosmic web is one of the most extraordinary structures in all of science, a vast three-dimensional network of filaments and sheets and nodes that was already beginning to take shape in the density variations of the very early universe. Those same infinitesimal ripples in the distribution of matter that had first set the stage for the collapse of the primordial hydrogen clouds along the densest filaments of this web. Gas and dark matter accumulated more quickly than in the surrounding voids, and it was along these filaments, at the nodes, where multiple threads of the web intersected, that the first galaxies began to form, not in a single dramatic event, but in the same slow, additive, patient way that everything in the early universe formed through the gradual accumulation of matter drawn by gravity from an ever wider region of surrounding space. The first galaxies were nothing like the grand spirals and ellipticals we see in deep field telescope images today. They were small, irregular, and clumpy, dense concentrations of a few million to a few billion stars, wrapped in halos of dark matter, their shapes determined not by any elegant organizing principle, but by the chaotic and constantly shifting balance of infall and rotation, and the gravitational influence of neighboring structures. They were, in the most literal and most peaceful sense, works in progress, assembling themselves from the available material with no blueprint and no destination, simply responding to the forces acting on them moment by moment across millions of years. And yet, for all their irregularity, for all their small size relative to the galaxies that would eventually form from their merging and growing over billions of years, these first galaxies were doing something of profound importance. They were concentrating their stars closely enough together that the collective ultraviolet light from all those burning population II and residual population III stars began to have a significant effect on the surrounding intergalactic medium, where a single star's ionizing radiation could carve out only a modest bubble of transparent space before being diluted by distance and absorbed by the surrounding neutral gas. A galaxy containing millions of stars produced a combined output of ionizing photons so much greater that its sphere of influence extended much further into the surrounding dark. And as neighboring galaxies grew and their own HII regions expanded, those regions began to approach one another, their boundaries drawing closer across the dark intergalactic gas that separated them. This was the beginning of the era that astronomers describe as the percolation phase of reionization, the period when the individual ionized bubbles surrounding the first galaxies grew large enough to begin touching and merging with one another, gradually linking up into larger and larger volumes of transparent ionized space, the darkness between the galaxies slowly retreating as more and more of the intergalactic hydrogen was stripped of its electrons by the combined starlight of a universe that was becoming, with each passing million years, measurably brighter, measurably more open, measurably more like the transparent and luminous cosmos we inhabit today. As you drift here in the soft and comfortable quiet of this calming bedtime story, feeling the deep and restful pull of sleep drawing you gently and inevitably downward, like a slow and warm current in a deep and still and perfectly dark body of water, you can let that image of the percolating universe rest lightly in your mind. Bubble touching bubble, darkness giving way to light, not all at once, but slowly and quietly, and without drama, the universe opening itself like the gradual brightening of a sky that has been dark all night long. The first faint graying of the horizon that tells you, without any urgency, that the long dark is ending. Rest here now, easily and without any effort at all, letting the quiet of this nighttime story wrap around you like the softest and most familiar of all the silences you have ever known, the particular silence of a room at night when everything outside has grown still and everything inside has grown slow, and the only thing moving is your breath, in and out, gentle and reliable, and entirely without urgency, just as the universe itself moved through this next great chapter of its long and patient story. Not with urgency, not with drama, but with the same slow and inevitable quality of something that has always been going to happen and is now, finally, quietly, beginning to arrive. The ionized bubbles we left drifting toward one another at the close of the last part of this sleep story were growing from every direction simultaneously, each one centered on a cluster of young and burning stars, each one pressing outward at its edges into the surrounding neutral hydrogen gas, each one slightly different in size and shape, depending on how many stars its host galaxy contained and how long those stars had been burning, and how dense the surrounding gas was in that particular corner of the expanding cosmic web. There was no coordination between them, no signal passing from bubble to tell each one where the others were or when to merge. Only the blind and patient expansion of light in every direction from every source, and the equally blind and patient absorption of that light by every neutral hydrogen atom it encountered. The same simple transaction repeated across uncountable distances in uncountable locations until the edges of neighboring bubbles finally reached one another, and the ionized gas from one flowed seamlessly into the ionized gas of the other, the boundary between them dissolving without ceremony, without any event that an observer could have pointed to and called a moment, simply a gradual, continuous, entirely peaceful unification of two volumes of transparent space into one larger volume, the darkness between them replaced not by anything new, but simply by the absence of the neutrality that had been there before. This merging process, repeated again and again across hundreds of millions of years, as more galaxies formed and more stars ignited and more bubbles expanded and more boundaries dissolved, is what drove the universe from its state of near total neutrality at the end of the cosmic dark ages toward the state of near total ionization that it reached approximately 1 billion years after the Big Bang, the state it has maintained ever since, the state that allows light from the most distant galaxies we can observe to travel across billions of light years of intergalactic space and reach our telescopes without being absorbed by the intervening hydrogen gas, the state that makes the observable universe transparent, open, legible, available to be studied and wondered at, and told as a gentle story on a quiet night to someone resting in the comfortable dark. The transition was not uniform across the universe. Some regions reionized earlier than others, those closest to the densest clusters of young galaxies, the nodes of the cosmic web where star formation was most vigorous and most sustained. Other regions, the great voids between the filaments where matter was sparse and galaxies few, remained neutral for longer, their darkness retreating more slowly before a light that reached them later, and more diluted than the light that had already cleared the denser regions. The universe reionized the way a fog lifts on an uneven landscape, clearing first over the hills where the air is moving, lingering longest in the low valleys where it has settled most deeply. The overall effect, a gradual and uneven brightening that nonetheless moved steadily and irresistibly in one direction, from dark toward light, from opaque toward transparent, from the profound and ancient silence of the cosmic dark ages toward the luminous and structured cosmos that would eventually give rise to everything you have ever seen or known or loved. As you lie here in the gentle darkness of your own room, your body heavy and soft and still, your mind drifting slowly downward through the comfortable layers of a deep and restful sleep that is drawing closer with every slow and easy breath. You can let the image of that gradual brightening universe move through your awareness like a dream that does not demand to be remembered, only to be felt. The slow lifting of an ancient fog, the quiet percolation of light through dark, the universe breathing out after the longest held breath in the history of everything, opening gently, opening completely, opening into the vast and luminous transparency that it has worn ever since, patient and radiant and entirely at peace. Allow yourself to sink even deeper now into the soft and weightless comfort of this calming narration, your body completely still, your breath moving in and out in long and easy waves, your thoughts growing quieter and more distant with every passing moment, like voices heard from the far end of a very long and very peaceful corridor, present but not demanding, familiar but not urgent, simply there, the way the universe itself was simply there through all the long and patient eras of its own slow brightening. We have been watching the ionized bubbles grow and merge across the densest regions of the cosmic web, watching the light from the first galaxies press steadily outward into the neutral hydrogen gas that had filled the universe since recombination. And in this part of our gentle sleep story, we turn our attention to the places that the light reached last. The great cosmic voids, those vast and almost empty regions of space that lie between the filaments and nodes of the cosmic web, where matter is sparse and galaxies are few. And the darkness that began with the cosmic dark ages lingered longest, holding its ground with the same quiet patience that had characterized the universe's long pre-stellar era. The voids are among the largest structures in the observable universe, stretching across tens of millions, and in some cases, hundreds of millions of light years, their interiors containing so little matter compared to the filaments surrounding them that they feel when you hold the image of them gently in your mind, like the spaces between the threads of a vast and loosely woven fabric, the places where the weave opens up and you can see through to the other side, empty and still and possessed of a particular quality of silence that is different even from the silence of the denser regions, deeper somehow, more absolute, more reminiscent of the original dark that preceded every star during the epoch of reionization. As the ionized bubbles surrounding galaxy clusters expanded and merged through the denser regions of the cosmic web, the voids received the light later and more gently than the regions around them, the ionizing photons arriving not directly from nearby galaxies, but filtering in from the edges of the already cleared regions on either side, a slow and diffuse illumination, rather than the direct and vigorous reionization that had cleared the denser filaments and nodes. This meant that the last neutral hydrogen in the universe was not concentrated in any single place, but scattered through the interiors of these great voids, slowly being reached by the expanding light from galaxies too distant to see clearly, its neutrality eroding not in a dramatic final clearing, but in the same gradual, unhurried way that the rest of the reionization had proceeded, one photon exchanged for one freed electron at a time, across distances so vast that the process moved more slowly than anything in human experience, and yet moved, always and without ceasing, in the same direction toward the complete and total transparency that the universe would achieve by approximately 1 billion years after the Big Bang. There is something extraordinarily calming about the image of those last pockets of neutral hydrogen in the deepest and emptiest voids, receiving the light so much later than the rest of the universe, resting in their ancient neutrality for a few 100 million extra years, while all around them, on scales they could never have been aware of, the cosmos was becoming transparent and luminous and alive with the light of millions of young galaxies. They were the last quiet places in a universe that was learning to shine, the final remnants of the dark that had preceded everything, dissolving slowly and gently and without resistance into the growing brightness around them, not because they were defeated, but simply because the light had finally, inevitably, patiently found its way to them across the vast and beautiful emptiness of the space between the galaxies. As you rest here in your own quiet dark, breathing slowly and feeling the deep and comfortable pull of sleep drawing you gently downward into the warm and wordless rest that your body has been waiting for since the day began. You can let the image of those last dissolving pockets of ancient darkness become your own resting place for a moment. Somewhere cool and still and immeasurably old, where the light is only just arriving, soft and diffuse, and entirely without urgency, touching the last of the dark with the same patient gentleness that the universe has brought to every step of its long and extraordinary journey, from silence to light, from emptiness to complexity, from the absolute dark of the cosmic dark ages to the luminous and transparent cosmos that holds you now, gently and completely. As you drift toward sleep, let yourself rest completely now, your body soft and still and perfectly supported, your breath moving in its own quiet rhythm without any guidance from you at all, slow and deep and easy. The way breathing becomes when the mind has grown quiet enough to simply allow the body to do what it has always known how to do without being asked or reminded or directed in any way. This part of our gentle bedtime story arrives at one of the most profound and most quietly beautiful thresholds in the entire history of the cosmos. The moment, approximately 1 billion years after the Big Bang, when the last of the neutral hydrogen in the intergalactic medium was finally ionized, when the final wisps of the ancient fog that had persisted since recombination dissolved completely into the surrounding plasma, and the universe became, for the first time since that early post-recombination glow had stretched itself into invisibility, fully and completely transparent, a cosmos through which light could travel freely in every direction across any distance, without being intercepted and absorbed by the neutral gas that had for so long stood between the sources of that light and the vast open space surrounding them. This moment is not marked by any explosion or any visible event. There is no sharp boundary in time that an observer could have pointed to and said, "Here, at this precise instant, the last neutral hydrogen was ionized and the universe became transparent." Instead, it was a threshold crossed gradually, a quality of the intergalactic medium shifting from mostly ionized to almost entirely ionized to completely ionized across a span of hundreds of millions of years. The final fraction of neutral gas dissolving so slowly that the transition was imperceptible on any timescale shorter than the geological ages of an entire planet, and yet the result was absolute and enduring. A universe so thoroughly cleared of obscuring neutral gas that the light from galaxies billions of light years away could now travel in straight lines across the full breadth of the observable cosmos and arrive, billions of years later, at the mirrors of telescopes built by creatures made of the very stardust that those early galaxies had scattered across the dark. The transparency of the universe is something so fundamental to how we experience and understand the night sky that it is easy to take it entirely for granted, to look up on a clear night and see the stars and the distant smudge of a far galaxy, and not pause to consider that you are only able to see them because the space between you and them is empty of the one thing that would block the view, the neutral hydrogen that once filled that space completely, and that was cleared away, slowly and patiently and entirely, by the light of the first stars and the first galaxies over the course of the universe's first billion years. Every time you have ever looked at the night sky and felt that particular quality of stillness and wonder that open space above a dark and quiet place can produce, you are experiencing the legacy of the cosmic dark ages and the epoch of reionization, the long, patient process of a universe clearing its own air, opening its own windows, making itself legible to the eyes and instruments of whatever minds might eventually arise within it to look and wonder and ask questions about where all of this came from and how long it has been here. As you drift here in the soft and comfortable darkness of this relaxing story, feeling sleep gathering around you like a warm and familiar tide, rising slowly and inevitably from the deepest and most restful parts of your own quiet mind. You can let that thought rest gently in your awareness without asking anything of you, without requiring you to hold it or analyze it or carry it anywhere. Simply the knowledge, soft and warm and ancient, that the darkness above you on any clear night is a cleared and open darkness. A darkness that was earned through a billion years of patient light pressing outward through the cold and neutral fog of the early universe. A darkness that is not empty, but full of the freely traveling light of 1 trillion stars in 100 billion galaxies. All of it moving through a cosmos that learned, slowly and without urgency, to let its own light through, just as you are learning now, in this moment, in this quiet, to let go of the last of the day's tensions and the last of the mind's restless movements, and simply rest, fully and completely, and without reservation, in the deep and transparent dark of a universe that has been preparing this moment of stillness for you since long before the earth existed. Let your breath continue its slow and easy movement, in and out, soft and deep and entirely effortless, and allow this gentle nighttime story to carry you now into one of the most quietly astonishing facts in all of modern science. The fact that the light from this era, from the very epoch we have been drifting through together in this calming narration, the light from the first galaxies and the first stars of the reionization era, is not lost, not vanished into an unreachable past, but is still traveling, still moving through the transparent intergalactic medium that was cleared so patiently over the universe's first billion years, still arriving at our instruments and our mirrors and our detectors right now, tonight, as you lie here in the comfortable darkness of your room. And let this sleep story wash over you in long and gentle waves. The James Webb Space Telescope, launched in late 2021 and positioned at a point in space approximately 1.5 million kilometers from Earth, has been gathering this ancient light with a mirror so large and so cold and so exquisitely sensitive that it can detect the infrared glow of galaxies that formed when the universe was less than 400 million years old. Galaxies so distant that their light has been traveling toward us for more than 13 billion years, stretched by the expansion of the universe from the ultraviolet wavelengths at which it was originally emitted all the way down into the infrared. The same gentle warmth you feel from a radiator on a cold night, arriving at Webb's detectors as the oldest and most traveled light in the observable cosmos. When astronomers look at the images produced by this telescope, they are not seeing the past the way you might see a photograph of something that no longer exists. They are receiving light that actually left those galaxies during the era we have been exploring together in this bedtime story. Light that was emitted by young stars burning in irregular proto-galaxies during the percolation phase of reionization. Light that has been traveling through the expanding transparent universe for longer than the Earth has existed, longer than the sun has burned, longer than the solar system has been a solar system, arriving now, in this moment, carrying within its spectrum the chemical fingerprints of the gas through which it passed, and the stars that emitted it, and the era of the universe in which those stars were young. There is something in that fact that feels, when you hold it very gently and without any urgency, like a kind of cosmic tenderness. The universe sending messages across its own full breadth of time and space, messages that take 13 billion years to arrive, that are written in the language of light and decoded by the instruments of a civilization that did not exist until the universe was already more than 9 billion years old. Messages that say, in the only language the universe has ever spoken, here is what it was like at the beginning. Here is the light that first cleared the dark. Here is the glow of the first galaxies in the first billion years, received and read and wondered at by creatures made of the very stardust, those galaxies scattered across the cosmos in their first supernovae. Creatures lying awake on a small blue world on the edge of an ordinary galaxy, looking back across the full span of cosmic time with instruments made of glass and metal and light, and feeling, in the presence of that ancient signal, something that has no precise name, but that lives somewhere between awe and gratitude, and the particular peace that comes from understanding, even incompletely, even approximately, even only in the softest and most general outline, where you are and how long everything has been here, and how patient and how generous the universe has been in keeping the record of its own beginning available for anyone with eyes and instruments, and the quiet curiosity to look as you drift here now in the deep and comfortable stillness of this relaxing story, your body heavy and soft and entirely at rest, your mind growing quieter with every slow breath. You can let that ancient light become part of the darkness around you, not a brightness that disturbs your rest, but a warmth that deepens it, the knowledge that the universe has been telling this story for 13 billion years and is still telling it, still sending its oldest light across the full transparency of the cosmos to wherever there is someone quiet enough and still enough to receive it. And tonight, in this moment, that someone is you, resting here, breathing slowly, already more than halfway into the deep and wordless country of sleep. Allow yourself to sink even more deeply into the stillness surrounding you right now, your body completely released into the comfort beneath you, your breath so slow and so quiet that it barely disturbs the air, your thoughts moving like the last few ripples on the surface of a lake that has been undisturbed for a very long time, growing smaller and softer and further apart with every passing moment until the surface is nearly smooth, and the reflection of the night sky above it is nearly perfect. And the whole scene is so still and so quiet and so complete that there is nothing left to do and nothing left to think, and only the gentlest and most effortless kind of listening remains, the kind that does not even require attention, only openness, only the willingness to let the words of this calming bedtime story arrive and dissolve, and carry you forward into the deep and restful sleep that is already very close now, already present at the edges of your awareness, like the first warmth of a morning that has not quite arrived, but is unmistakably on its way. We have traveled together through the cosmic dark ages and the epoch of reionization, through the birth and death of the first stars, through the slow gathering of the first galaxies and the patient merging of their ionized bubbles, through the final clearing of the last neutral hydrogen in the great cosmic voids, and through the extraordinary fact that the ancient light from all of that is still arriving at our instruments tonight as you rest here in your quiet room. And now this gentle sleep story turns to something even older than the light of the first stars, something that predates every galaxy and every stellar generation and every act of fusion in the history of the cosmos, the oldest light in the universe, the cosmic microwave background, that faint and ancient glow released at the moment of recombination. Nearly 13.8 billion years ago, the universe's first and most enduring lullaby, still singing in every direction simultaneously, still filling every corner of the cosmos with its soft and ancient warmth, still arriving at our instruments from the edge of the observable universe. In every direction, we point our most sensitive detectors, the cosmic microwave background, or CMB, as astronomers call it, with the easy familiarity of long acquaintance, is the thermal afterglow of the early universe, the light that was released when the cosmos cooled enough for electrons and protons to combine into neutral hydrogen atoms, and the previously opaque fog of free electrons finally cleared, allowing photons to stream freely for the first time in cosmic history. That light has been traveling ever since, stretched by the expansion of the universe from the visible and near-infrared wavelengths, at which it was originally emitted, to the microwave wavelengths, at which we now detect it, cooled from a temperature of nearly 3,000 degrees at the moment of its release, to just 2.7 degrees above absolute zero today, a whisper of warmth so faint it took humanity until 1965 to detect it, and even then it was discovered not by a deliberate search, but by two radio astronomers who noticed a persistent, gentle hiss in their antenna that they could not explain. And that turned out, upon investigation, to be the oldest sound the universe has ever made, the echo of its own beginning still reverberating through every instrument sensitive enough to hear it. When you picture the CMB now, drifting here in the deep and comfortable dark of this nighttime story, you might let it become not a scientific abstraction, but a felt presence, a warmth so ancient and so evenly distributed that it is literally everywhere simultaneously, surrounding you on all sides, arriving from every direction at once, the universe holding you gently inside the memory of its own first light, the way A room holds the memory of warmth long after the fire has gone out. Not hot, not even perceptibly warm to human senses, but present, entirely and unchangingly present. A background of ancient tenderness that has been accompanying every moment of your existence without your ever needing to know it was there. The small variations in the temperature of the CMB, tiny fluctuations of 1 part in 100,000 across the sky, are the imprint of those original density variations in the early universe, the same infinitesimal ripples that seeded the collapse of the first hydrogen clouds and the formation of the first stars and the gathering of the first galaxies. Written in the oldest light we can observe, preserved across nearly 14 billion years of cosmic expansion, available to be read by anyone patient enough and quiet enough to listen. The universe's most ancient record of how it began, still present, still intact, still whispering its origin story in every direction at once. A lullaby that began before the first star and will continue long after the last one fades, carrying you now, gently and completely, toward the deep and dreamless sleep waiting just beyond the next slow breath. Let your body rest completely now. Every last trace of tension dissolved into the soft and comfortable darkness surrounding you, your breath so slow and so easy and so entirely without effort that it has become indistinguishable from the general stillness of the room, your mind drifting in that warm and borderless place between waking and sleeping, where thoughts arrive not as sharp and insistent things, but as soft and shapeless impressions that form and dissolve and form again without demanding anything from you, without asking to be followed or analyzed or remembered, simply present for a moment and then gone. The way clouds move across a very dark and very quiet sky without anyone needing to watch them. This part of our gentle sleep story turns to something that has been present in every chapter we have shared together, and yet has never been directly named, something without which none of the wonders we have drifted through together would have been possible. None of the first stars, none of the first galaxies, none of the slow and patient gathering of hydrogen into the structures that eventually gave the universe its light. The invisible scaffolding of dark matter, the silent and mysterious substance that makes up approximately 85% of all the matter in the universe, and that interacts with everything we can see and touch and measure only through the one force it shares with ordinary matter, the slow and patient and entirely reliable force of gravity. Dark matter does not emit light. It does not absorb light. It does not interact with the electromagnetic force in any way that our instruments have yet been able to directly detect. And yet, its presence is written unmistakably into the structure of everything we observe, in the rotation, curves of galaxies that spin too fast at their edges to be explained by the visible matter they contain, in the gravitational lensing of distant light around clusters of galaxies that bend space more strongly than their visible mass alone could account for, in the large-scale distribution of galaxies across the cosmic web, whose filaments and nodes and voids trace almost exactly the pattern predicted by models in which dark matter provided the initial gravitational seeds around which ordinary matter accumulated in the early universe. It was dark matter that first began to cluster after the Big Bang. Its particles, whatever they ultimately proved to be, free from the pressure that kept ordinary matter so uniformly distributed in the hot early universe, able to begin gravitationally clumping even before recombination, building invisible halos of mass that would later act as the gravitational wells into which ordinary hydrogen and helium gas would flow when the universe cooled enough to allow it. The first stars formed not simply because hydrogen gas collapsed under its own weight, but because that hydrogen gas fell into the gravitational potential wells of dark matter halos that had been quietly deepening for hundreds of millions of years before the first proton ever joined another proton in a fusion reaction. Dark matter was the silent architect of the first light, the invisible framework upon which the visible universe assembled itself, present and active, and gravitationally decisive throughout every era we have explored in this calming narration. From the cosmic dark ages through the epoch of reionization and beyond, its influence as patient and as persistent, and as entirely without urgency as everything else in the deep history of a cosmos that has never once been in a hurry to arrive anywhere. As you drift here now in the deep and wordless comfort of this nighttime story, your body completely still, your mind floating in that soft and borderless space that is neither fully asleep nor fully awake, but something gentler and more restful than either. You can let the idea of dark matter become a felt presence rather than an abstract concept, the invisible embrace of a universe that holds all of its visible light and all of its burning stars and all of its complex chemistry and all of its patient beauty within a framework of quiet gravitational love so vast and so evenly distributed that it touches everything simultaneously and demands nothing in return, simply holding, simply keeping, simply ensuring that the luminous and intricate cosmos that emerged from the cosmic dark ages remains gathered and structured and coherent, rather than dispersing into a featureless and lightless infinity, the universe holding itself together in the dark with the same silent and entirely reliable tenderness with which the darkness of your room holds you now, gently and completely, and without asking anything of you at all, as you drift closer and closer to the deep and restful sleep that has been waiting for you all along. Let your breath come and go now in the softest and most effortless way. Barely a movement at all, barely a sound, just the gentle and automatic rising and falling of a body that has grown so deeply comfortable and so completely still that it no longer needs any instruction or any guidance from the mind that has been slowly, quietly, beautifully releasing its grip on the day. Since the very first words of this relaxing story began to wash over you in long and easy waves, we have drifted together through so much of the universe's earliest history, through the darkness before the first star and the birth of that first blazing giant, and the slow death that scattered its gifts across the surrounding dark. And in this part of our gentle bedtime story, we return to those gifts, to the heavy elements that the first supernovae released into the interstellar medium to follow them a little further into the story of what they became and what they made possible. Because the journey of those first metals, as astronomers call any element heavier than hydrogen and helium, regardless of whether it is actually a metal in the everyday sense of that word, is one of the most quietly extraordinary journeys in the history of everything, a journey that begins in the core of a dying star and ends billions of years later in the bodies of every living thing that has ever existed on every world that has ever harbored life anywhere in the observable cosmos. When the first population III stars ended their lives in core collapse supernovae, the heavy elements forged in their interiors were not simply mixed uniformly into the surrounding gas and forgotten. They were carried outward in the expanding supernova remnant at velocities of thousands of kilometers per second, plowing into the surrounding neutral hydrogen, compressing it into dense shells, enriching it unevenly, creating pockets of relatively metal-rich gas surrounded by the still pristine primordial hydrogen and helium that had not yet been touched by any stellar wind or any supernova shockwave. This uneven distribution of the first metals meant that the second generation of stars forming in the enriched regions would be chemically different from stars forming simultaneously in the unenriched regions nearby. And this chemical variety, this first breaking of the universe's original uniformity into a patchwork of different compositions and different histories, was the beginning of the extraordinary diversity of stellar and planetary chemistry that would eventually produce worlds as varied as the gas giants and the rocky planets and the icy bodies of our own solar system. The carbon that entered the early interstellar medium from the first supernovae was not simply a passive ingredient waiting to be incorporated into the next generation of stars. It was, even in the cold and dark of the interstellar gas, chemically active, capable of forming simple molecular bonds with hydrogen and oxygen atoms in the cold, dense clouds where new stars were beginning to form, producing the first simple organic molecules, the most basic precursors of the chemistry that would eventually, over billions of years and many stellar generations, lead to the complex carbon chemistry of living things. These first tentative molecular bonds forming in the cold, dark gas of the early universe are among the quietest and most tender facts in all of astrophysics. The universe beginning, almost imperceptibly and entirely without fanfare, its long and patient experiment with the chemistry of complexity, laying down the first faint threads of a molecular tapestry that would take billions of years to weave into anything recognizable as the chemistry of life, but which began here in the cold and enriched dark between the first and second generations of stars, in the gentle joining of a carbon atom and a hydrogen atom in a cloud of gas that had never before contained anything more complex than a single atom of the simplest element in existence. As you rest here in the deep and comfortable stillness of this calming narration, your body completely released into the warmth and support surrounding you, your mind floating in that soft and luminous half-darkness that lies just above the surface of deep sleep, like a warm and weightless layer of something neither air nor water, but gentler than both. You can let that image of the first molecular bonds forming in the cold interstellar dark become a kind of companion to your own rest, the universe beginning its slow and patient journey toward complexity and life in the same quiet dark where you are now drifting toward the deep and dreamless sleep that restores and renews and makes everything possible again. The first chemistry of the cosmos unfolding in the dark with the same unhurried patience that deep and genuine rest unfolds in you. One slow breath at a time, one quiet moment dissolving into the next. Let yourself go completely now. Every last thread of wakefulness dissolving into the deep and beautiful dark that has been waiting for you so patiently through all the long and gentle hours of this sleep story. Your body so soft and so still and so entirely at rest that it has become part of the quiet of the room itself. Your breath so slow and so shallow and so utterly effortless that it moves without you, the way the universe itself moves without anyone directing it, without anyone needing to hold it together, simply continuing in the only direction it has ever known, forward and outward, and deeper into the extraordinary mystery of its own existence, carrying everything within it, carrying you within it, through the dark and through the light, and through every patient and unhurried moment in between. We have traveled so far together in this calming narration, you and this voice, and the long and luminous story of a universe that began in silence and darkness and taught itself, one patient stellar generation at a time, to shine. We have drifted through the cosmic dark ages when there was nothing but cold hydrogen and the invisible pull of gravity and the slow and unstoppable mathematics of collapse. We have watched the very first star ignite in the dark, a single blazing point of light in an infinite and previously unlit cosmos, carving out the first small bubble of transparency in a universe that had never before known what it meant to be seen. We have followed the light of that first star as it traveled outward into the surrounding neutral gas, and we have watched the first star die and scatter its gifts of carbon and oxygen and iron across the dark for the generations that would follow. We have seen the second generation of stars ignite, smaller and longer-lived and richer in chemistry than their predecessors, and we have watched the first irregular galaxies gather at the nodes of the cosmic web and begin to pour their collective light into the surrounding dark until the ionized bubbles surrounding them grew large enough to find one another and merge slowly and without ceremony into larger and larger volumes of transparent space. We have rested in the great cosmic voids where the darkness held its ground the longest, watching the last of the ancient neutral hydrogen dissolve quietly into the growing brightness of a universe, crossing the threshold of complete transparency. And we have marveled at the fact that the light from all of it is still traveling, still arriving, still carrying its 13 billion year message across the full breadth of an expanding and luminous cosmos to wherever there are eyes and instruments and quiet minds willing to receive it. And underneath all of it, woven through every chapter of this long and gentle bedtime story, the cosmic microwave background has been present. The universe's oldest lullaby, 2.7 degrees above absolute zero, arriving from every direction simultaneously. The softest and most ancient warmth in existence, surrounding you right now as it has surrounded every moment of your life without your ever needing to know it was there. The universe holding you inside the memory of its own first light with a patience and a tenderness that makes every other kind of patience and tenderness feel young by comparison. You are made of this story. Every atom in your body was forged in a star that lived and died before the sun was born, scattered across the dark by a supernova that enriched the cloud from which your star and your world. And eventually you were made, the carbon in your cells, and the iron in your blood, and the calcium in your bones, all carrying within their nuclei the memory of the stellar cores where they were assembled, all of them children of the cosmic dark ages and the epoch of reionization, and the long and patient brightening of a universe that began in absolute silence and has been learning to shine ever since. And now the story rests, the way the universe itself rests between one stellar generation and the next, in the deep and comfortable dark, where everything that will happen next is quietly gathering its strength, where the next wonder is already forming in the patient dark, the way a dream forms in the mind of someone who has finally, completely, and beautifully fallen asleep. Rest now. The universe is still here. The ancient light is still traveling. The first stars are still remembered in the chemistry of everything around you and within you. And this gentle nighttime story will be here whenever you need it again, waiting in the same patient dark where all good things wait, quietly and without urgency, for the moment when you are ready to return. Sleep deeply, sleep peacefully, sleep well.